Today we're going to multiply rational expressions, but before we actually get into multiplying rational expressions, we're going to simplify rational expressions. To simplify these, rational expressions just means there's a fraction involved. There's a numerator and a denominator. We are going to do our favorite thing in the whole wide world. What's our favorite thing in the whole wide world? Factoring. We're going to factor. So, in this first example, if I'm going to factor this numerator, we are looking for, my pen's not working. We're looking for two numbers that multiply to give us -12. Those same numbers need to add up to -4. 1 times 12, that's not going to work. 2 times 6. 2 times -6 is -12. 2 plus -6 is -4. So x plus 2, x minus 6. On the bottom, we have x squared minus 4. This is only two terms. When you only have two terms, it's either greatest common factor or difference of two squares, or it just can't be factored anymore. It's not greatest common factor because x squared and 4 don't have anything in common, but do you notice that 4 is a perfect square? So the square root of x squared is x, the square root of 4 is 2. This factors into x plus 2 times x minus 2. So remember, this type is called the difference of two squares. Anytime you see x squared minus and then a perfect square, we're difference of two squares. Once you have the numerator and the denominator factored, now it's my favorite part. Now we get to cross things off. This feels like slashing through math, and it's, I don't know, I get a thrill from it. What do you see on the top that matches the bottom? The x plus 2 will cancel out the x plus 2. And our final answer here is x minus 6 over x minus 2. Okay, warning though, I don't want you to try to take this further than you're able to. X plus 2 can be canceled because it's x plus 2 times x minus 6, and it's x plus 2 times x minus 2. You can cancel factors. You can cancel things that are being multiplied. You cannot cancel things that are being added or subtracted. So in this answer, we could not cancel these x's because x is being subtracted by 6, x is being subtracted by 2. These are actually called addends and subtrahends, not factors. Now if it was x times x minus 6 over x times x minus 2, then we could cancel them because it's x times those things. You can cross out things that are being multiplied. You cannot cross out things that are being added or subtracted. Why don't you try number 2 on your own? Pause the video, give it a try on your own. You're looking for two numbers that multiply to give you -6 and add up to -5. So it's probably, yeah, it's not 2 and 3. Definitely not 2 and 3. It's 1 and 6, and the 6 would have to be negative. So x plus 1, x minus 6. The bottom is x squared minus, and some of you forget that 1 is actually a perfect square. What's the square root of 1? 1. So x plus 1, x minus 1. Then my favorite part, x plus 1 cancels x plus 1, and our final answer is x minus 6 over x minus 1. Now, if you find yourself tempted to try to cancel more when you aren't able to, it is perfectly fine to leave parentheses around those so that you know that that x minus 6, it's like that's a factor in and of itself. It can't be split up. So if you want to keep your parentheses around it, totally fine. If any of you have worked ahead to number 3, you might have noticed something frustrating about the top. Two numbers that multiply to give us -4 are not going to add up to 10. This top part is not factorable. Basically, I put this example in here specifically so that you would see that just because you've got x squared plus 10x on the top and x squared plus 10x on the bottom, you can't cancel those because x squared plus 10x minus 4 is one whole statement, and you wouldn't be able to split it up and cross things off unless you could factor it. So because it's not factorable, you can't simplify this. This is basically as simple as it gets. The one thing that we could do, this can be factored using greatest common factor. Do you remember greatest common factor? What do x squared and 10x have in common? X. X squared, pull an x out, you're left with x. 10x, pull the x out, you're left with 10. So the bottom of that thing could be factored into x times the quantity x plus 10, but we still can't cross anything out. So this is as simplified as this one gets. When we have no addition and no subtraction, so we've got two different numerators, two different denominators, there's no addition or subtraction on either of the numerators or denominators. You want to combine the entire top. So I've got 5 times 6, that gives me 30. X squared times x to the third gives me x to the fifth. And then y times y squared gives me y to the third. On the bottom, I'm going to do the same thing. 2 times 10 is 20. X times, there's just the x. And y to the third times another y would be y to the fourth. Do you remember this from chapter 5? This is definitely a review from chapter 5 when we did properties of exponents. So the 30 over 20, that is a fraction. That is the fraction 30/20ths. You want to simplify that fraction. What can you divide out of both 30 and 20? 10. So really what this chapter would want you to do is write down that this is 3 times 10 and 2 times 10, and then cancel the 10s out. But basically that means we're going to end up with a 3 on the top and a 2 on the bottom. Oh my gosh. Okay, then the x's. X to the fifth over x. If you remember from chapter 5, it's division, so we would subtract the exponents. 5 minus 1 is 4, so we'd have x to the fourth. Here's how chapter 7 wants you to think about this. This is one factor of x on the bottom. The one factor of x is going to cancel out one of the 5 factors of x, leaving 4 factors of x remaining on the top. So I kind of made a mess of it, but basically it means that there's x to the fifth is like that, and x is like that on the bottom. They want one of the x's to cancel out one of the x's, so there's still 4 of them left on the top. So using that method of thinking, y to the third means that there's 3 y's on the top. Y to the fourth means that there's 4 on the bottom. The 3 on the top will cancel out 3 on the bottom, leaving 1 left on the bottom. So ultimately our answer here is 3x to the fourth over 2y. When it comes down to it, there might be one of these on each of your assignment, and there probably will not be any of these on the test, because really truly this is a review of chapter 5. I want to focus more on the factoring types of simplifying rational expressions. So let's move on to the next page. There are step-by-step instructions, but I don't want to go through step-by-step instructions until after we've seen an example. This is truly multiplying rational expressions. You've got a rational expression times another rational expression. There's 2 numerators, 2 denominators. I'm just going to start factoring. So starting with this one. This factoring is greatest common factor factoring. What do 4x squared and negative 4x have in common? 4x. So we're going to pull 4x out, and it's like we're dividing both of these terms by 4x. So 4x squared divided by 4x is going to result in x minus, what is 4x divided by 4x? 1. You must have a 1 there, not a 0. It doesn't just go away. There has to be a 1. Remember that what we're doing is undoing the distributive property. If I were to multiply this back together, 4x times x is 4x squared. 4x times negative 1 is negative 4x. That 1 has to be there so that that term is still there. Next, I'm going to factor the other numerator, which is a normal trinomial, so I'm looking for two numbers that multiply to give me negative 6 and add up to 1. That would probably be 2 and 3 with a negative 2. So x minus 2, x plus 3. Notice I didn't put two separate fraction bars. It doesn't matter which numerator it's on. They're both numerators, so I'm putting both of the factored forms in the numerator of my next step. All right, next up we've got this trinomial. We're looking for two numbers that multiply to give us negative 3 and add up to 2. Well, it's got to be 1 and 3 with a negative 1. And then the last denominator just is kind of chilling there. We got 4x chilling. Okay, my favorite part. What do you see on the top that matches the bottom? 4x, x minus 1, x plus 3. What's left? Okay, you got to admit it's kind of awesome that that super complicated looking problem and the final simplified answer is just x minus 2. Like that's kind of cool. Pause the video and give number 7 a try on your own. Honestly, I love this problem because there are two trinomials for you to factor, and there's a difference of two squares to factor right here, and there's a greatest common factor for you to factor here. If you're just looking at the video and not looking at a paper copy of the notes, by the way, there's a 5 right here. That's 15, because it's definitely not factorable if it's just a 1. So that's definitely supposed to be a 15, not just a 1. Okay, two numbers that multiply to give us 15, that would probably be 3 and 5, and it looks like they both need to be positive. For negative 8, I think that's 2 and 4, positive 4, negative 2. For the greatest common factor, these two terms have 2x in common, x plus 5. And then for the difference of two squares, it would be x plus 2, x minus 2. Then we start slashing. I see x minus 2, x plus 5, and that's it. So our final answer is x plus 3, x plus 4 on the top, and 2x, x plus 2 on the bottom. Okay, we are going to leave our answers in factored form. Quick note that this is the preferred answer format, not this one, because that's the one that Photomath gives you, and no, we want to leave our answers in factored form, not rely on Photomath for our answers. Okay, number 8 we aren't actually going to do. I just want to show you the format of this. If you don't see a denominator, this thing is over 1. So there is a denominator there, it's just 1. So that x squared plus 2x plus 1, when you factor that, that will be in the numerator, and there just isn't a denominator other than 1 there. On your worksheet for today, number 5, this is the numerator of the first fraction. I want you to rewrite it, and then this is how that first numerator is factored. So this is the factored version of the first numerator in number 5.